Hey students, this is the final lesson of the school year and this quarantine life. And then we just got one more PC. Again, today we're going to keep on doing applying volume and surface area. Again, there will be a PC later posted, probably on Wednesday or Thursday, but please do the learning activity and cool down. You're more welcome to get help from me. Remember office hours, I post them daily and Tuesday to Thursday, and I'll give that announcement later this day, I guess. Today's Monday when I'm doing this. Okay, so we're going to use things that are proportional to volume or surface area. The goal today is to still use children's play structures and find the volume or surface area of them. Let's look at filling the sandbox for today, all right? We're going to look at a octagonal sandbox, I guess you can call it. Let me move my face, make it smaller. So we have here a regular hexagon, which is the shape of a sandbox for this activity. We need to start by calculating the area of it. Okay, think about this as we have kind of a rectangular square structure right here in general, but we have the dimensions of a sandbox that will fill up with a bunch of sand, right? But let's start first by finding the area. So we don't know the area of this hexagon, but I can find that if I was to cut this up, cutting through all those different corners of this hexagon, you would see that I would have triangles, right? Let's go ahead and try to find one of these triangles. Okay, actually, let me do this one right here, since that seems more obvious. Remember, the area of a triangle represents 1/2 times base times height. Looking at it, looks like I have a base right there, don't I? So this is equal to 1/2 times 21. Now you got to think about what the height is going to be. Well, if you look here, that's 36.4. Looks like it's getting cut in half. So I can say my height for this triangle is going to be half of 36.4, which is 18.2. All right. So my area of this triangle is 1/2 times 21 times 18.2. Let's go ahead and do the math of this. 18.2 times 21 divided by 2. I get 191.1. Let me double check some answers, make sure I get this right. All right, so if I have one triangle is 191.1, again, this is for one triangle. If I'm trying to find the whole area of that hexagon, how many triangles do I have? If you said 6, you are correct. So I got to take 191.1 times it by 6, right? The 6 triangles. Again, this represents 6 triangles. And this represents one triangle. One try. We times those together. Looks like my base is going to be about 1,146.6 inches squared, all right? So that's going to help us find out some other parts of this, but keep in mind this is going to be the area. This is the base area. Not surface area. This is the base area. So now I gotta fill the sandbox up. Looks like I'm filling it all the way up to 10 inches, right? Again, this looks like a prism to me, but I have here 10 inches is getting filled up, and then we have that remainder 3 inches left over. So if I'm filling a sandbox, remember if I'm filling something in, is that surface area or volume? If you said volume, you are correct. And this is equal to our base area times my height. So I found the base area to be 1146.6. I got to times that by my height. Well, my height is going to be that 10 inches right there. This is our height, right? So it's going to be times it by 10. So therefore, I know the volume of this sandbox, right? How much sand is getting filled up. Well, that's going to be 11,466. All right, that's how much sand. This is going to be in inches cubed of sand. All right, we're going to use that to solve these problems, all right? So number 1. So if it took 14 bags of sand to fill this small sandbox to this depth, What volume sand comes in one bag? So here we have 14 bags, right? That's important. So 14 bags. We need to find out the volume of one bag. So what did I say my total volume was? Well, my volume we found back here was 11,466. 11,466 inches cubed. I need to figure out how much is one bag. So we'll have 14 bags. Let's see, because that's how much it took. Well, that's going to equal to 11466 inches cube of sand, right? So we got to figure out how much is one bag going to be. So one bag, I know, is I could take the total number of volume, right, of 11,466, and I could divide it by 14, and that'll tell me how much I have for one bag, right? We have a total amount, we divide that into 14 different bags. Therefore, I know my answer has to be 819 inches. Let's see, 819 inches cubed of sand, right? That's how much one bag is equal to. All right. So what volume of sand comes in one bag? That will be this right here, 819 inches cubed. So if it's 819 inches cubed, here we're going to have the daycare manager wants to add 3 more inches to the depth of the sand, the small sand box. So it looks like he wants to fill it up. So now he's using that, filling up that extra 3 inches. How many bags of sand will they need to buy? Well, the first situation, again, take some time to pause and read this problem. I know I kind of skipped it over. Again, we have wants to add more inches to the depth of the sand. Basically, we're filling up to the brim. We're going to add 3 more inches to it. We need to figure out how much sand bags I need to add, bags of sand I need to add into that sandbox. So again, our volume is going to equal to our base area. We saw that base area to be not that number. We saw it to be 1146.6. So I got to do 1146.6. I need to times that by my height. What's going to be my height, class? So my height is going to be this 3 inches. So I'm going to times that by 3. So now I see that, okay, well, I'm trying to fill in that sandbox. I got to fill in 3,439.8 inches cubed of sand. So remember, we're trying to figure out how many bags of sand will I need to buy, right? So I found that one bag is equal to 819, right? Inches cubed sand. I need to figure out how many bags do I need, all right? So I'm trying to find bags. I know I have 3439.8 inches cube of sand. So then how do I find from volume to bags, right? How do I find that? Basically, we're going from 119 to one bag. We need to find that constant proportionality again, right? So I need to figure out, okay, what do I need to times 819 by to get 1? So I know that I need to times this by 1 over 819 or divide 819, right? So I'm going to take that total number of the 3 inches getting filled up. I'm going to times it by 1 over 819. So I do 3,439. So I got 3,439.8 times 819. I get 4.2 bags. 4.2 bags. But remember, we're going to buy bags. We can't buy 0.2 bags. So I'm going to say my answer is going to be 5 bags. All right. Again, pause this video, kind of go back over it, try this yourself, right? I gave you the answer, but you need to be able to process this, all right? We're using a bunch of concepts we learned in the past and putting it all together. Okay, let's take some small steps with this one. This one's pretty heavy, right? We got a lot of stuff going on here. So the daycare manager also wants to add 3 more inches to the depth of a sand in the large sandbox. So we had 2 sandboxes. What we just did was the small one. Now we got a large one, right? That we're going to add 3 more inches. So it is similar to this image, but it's a lot bigger, all right? So the base of the large sandbox is a scaled copy of the base of the small sandbox. The scale factor is 1.8. Let me use green. So how many bags of sand will they need to buy for the large sandbox? So this goes back to this picture right here, where remember how I said that kind of makes this rectangle shape? Don't worry about the diagonals. Well, I know that for the large sandbox. So let's say this was the large sandbox. Let me see if I can take this image and make a new thing right now, okay? There's that. You can't see those numbers. All right, let me put another slide. We're going to call this the large sandbox, all right? So remember, with the large sandbox, it has a scale factor of 1.5. So if these are the dimensions of the small sandbox, if I'm scale factoring, I'm going to times each of these by 1.5. And that's going to be the bigger one, okay? So really what's going on here is those are times by 1.5. I get new dimensions. Well, instead of just timesing it and finding the area all over again, what I can do is, since I know this is basically a rectangle right here, I know it's going to be length, width times length, right? Well, I'm going to say, I know it's getting scaled by 1.5, so I'm going to times both of those by 1.5. And that should give me, let's see, I'm trying to be precise here. That should give me 2.25. So really what's going on is the overall base, right? So the overall base of this sandbox, well, we found that the base area was 1,146.6. Well, that now is going to get multiplied by this scale factor of 2.25. Okay, so I take this base area of 1146.6. I'm going to times that by 2.25 because we got a bigger sandbox, right? We got to figure out the volume of that bigger sandbox. And that is going to be 1146.6 times 2.25. So now my new volume is going to be 2,579.85. So this is the large sandbox. Oops, this is in inches squared, but we can say this is for the large sandbox. Okay, so I want to add 3 more inches to it. So that's the volume of it, right? So now I know that my volume is going to equal the base area of the large sandbox, which is 2579.85, times the height I'm adding in, or the depth, which is 3, because that comes from the 3 more inches. And that gives me times 3. It's going to be a big number, but we get 7,739.55 inches cube of sand. Just for those 3 inches, right? So we remember this is the same situation, except we have a big sandbox. So look at that picture. We have a big sandbox now. We found the dimensions. We're finding that 3 inches. We saw that is equal to that amount, right? That 7,739.55 inches cubed. But I need to find out how many bags of sand will they need to buy for the large sandbox. Remember, 1 bag is equal to 819 inches cube of sand, right? What we did was we divided it by 819. So to get the number of bags, if I have here 7,739.55, I need to find the bags. I'm going to do the same thing by dividing by 819 or timesing times by 1 over 819, right? Those are the same things. So let's go ahead and do that. We do that divided by 819. I get 9.45 bags. Again, you can't have 0.5 of a bag, so I know I have to buy 10 bags of sand. It's a lot of math, isn't it? We're almost done. We got one more. Call it good. Okay, so we have a lawn and garden store selling 6 bags of sand for $19.50. All right, so we got this store selling bags for $19.50. How many will they spend to buy all the new sand for both sandboxes? Okay, so this time I have 2 sandboxes, right? I need a total of sand to fill up. Let me double check some ideas here before I don't get messed up. Let's see. You know what? I think, yeah. So let's go ahead and, oh, that's right. Okay, so when we looked at these situations, right, we saw that we needed 4.2 bags for this one, for the sandbox, and we needed 9.45 bags, right? So let me set this up. So what I'm trying to say is for the small, call it SB, we needed 4.9 or 4.2 bags, right? For the large SB, we needed 9.4, what was it, 9.45 bags. So I'm trying to buy bags for all of them now, right? But we saw that a garden store is selling 6 bags of sand for $19.50. So 6 bags equals $19.50. How much is one bag? So we need to figure out one bag. Yeah, can't write today. So if I'm trying to figure out one bag, remember it's going to be the constant proportionality, which is the second. So 6 bags, so bags to dollars, it's the second over the first, which should give me $3.25, right? Let me double check. Yep. So then one bag times the constant proportionality is $3.25. It's going to give one bag is equal to $3.25, right? That makes sense. So if I have a total of 4.2 bags for the small one, 9.45, let's add those together to get the total number of bags, right? That should give us 13.65 bags total. So if I have 13.65 bags, how much is that going to cost? Well, each bag costs $3.25, so I'm going to times that by $3.25. What's my answer? So we get 13.65. Oh, I forgot. Remember, we can't get 13.65. We have to buy rounded up, right? So really, I want 14. I want 14 bags. 14 bags. So then 14 bags times 325. That gives me 4. So my answer is $45.50. So that's how much money it's going to cost to fill up both of those sandboxes. We need 14 bags, so it'll cost us $45.50. Man, that's a lot of math. This stuff is actually pretty related to real life. I mean, if you're gardening, you're helping your parents out or whoever, right? But yeah, that's how you do that. Okay. So some questions to wrap it up. So did you use volume or surface area to help you answer any questions? We used both of them technically. The last sandbox question we used was particularly with volume, right? So how do we use volume and surface area to solve more complex real world problems? You may need to calculate volume or surface area to answer a bigger question like how much it would cost to build something, right? The overall picture is we use volume, surface area to figure out how much it would cost to build something. What other skills did you have to use to solve the problems in this lesson? Well, we use ratios, proportional relationships, again with that constant proportionality, some crazy stuff, right? And then many times in real world problems, calculating the volume or surface area is just a small piece of what is needed to be done. So honestly, this math that we learned throughout this year, right, it's a small piece of a bigger picture, right? If we're trying to make things relevant in real life, it gets really complicated. That's the conclusion of what I'm going to tell you about math in general, right? Is that the math we learn is just a small piece of how to do the bigger picture of math, which is a lot harder than it seems, right? That's why people go to college for it. But we are done. We're done, right? Done with the whole school year, done with the lessons. Now we just got one more PC, but you learned today, lastly, a volume and surface area. Okay, good job, class. I hope you felt good about it. Remember, there's a cool down with connected to this. Please get it done. Get your work done. We'll be done pretty soon, all right? But other than that, have a wonderful day. It's been a pleasure teaching you all, and I'll see you when I see you, right? Take care.